Chapter 16 Computer Networking. Hello students, welcome to the class. In this chapter, we will learn various skills of computer networking. This chapter will cover Introduction to Computer Networking, Overview, Basics of Computer Networking, Network Connections or Links, Wired Physical Network Link, Wireless Links, Network Protocols, Layers of Networking, Network Access Layer, Internet Layer, Transport Layer, Application Layer, Network Types, PAN, Personal Area Network, LAN, Local Area Network, Wireless LANs, WLAN, MAN, Metropolitan Area Network, WAN, Wide Area Network. Communication, sharing resources, sharing software, data sharing, centralized support and administration, network security issues, types and sources of network threat, security risks to home users, software and hardware issues in networking, initial configuration, credential, permission and rights problems, network performance, TCP, IP and other protocol problems, general security concerns. Introduction to Computer Networking. Overview. A computer network or data network is a telecommunications network which allows computers to exchange data. In computer networks, networked computing devices exchange data with each other along network links, that is, data connections. The connections between nodes are established using either cable media or wireless media. In other words, a computer network is basically a set of computers connected together for the purpose of sharing resources. The most common resource shared today is connection to the internet. Other shared resources can include a printer or a file server. The internet itself can be considered as a computer network. Basics of computer networking. Dear friends, in this section, we will cover the major basic components of computer networking, which can be classified into 7 parts. Network connections or links, network protocols, layers of networking, network types, network topology, network strategy, organizational scope of network, network bandwidth classification, network connections or links. The transmission media, that is often referred as the physical media, used to link devices to form a computer network primarily includes electrical cable, that is Ethernet, power line, optical fiber, that is fiber optic communication, and radio waves, that is wireless networking. Let's have a look on major types, which are a widely adopted family of transmission media used in local area network, that is LAN technology, is collectively known as Ethernet. The media and protocol standards that enable communication between networked devices over Ethernet are defined by IEEE 802.3. Ethernet transmits data over both copper and fiber cables. Wireless LAN standards, example those defined by IEEE 802.11, use radio waves, or others use infrared signals as a transmission medium. Power line communication uses a building's power cabling to transmit data. Coaxial cable, a type of wire that consists of a center wire surrounded by insulation and then a grounded shield of braided wire. The shield minimizes electrical and radio frequency interference. Coaxial cabling is the primary type of cabling used by the cable television industry and is also widely used for computer networks, such as Ethernet. Although more expensive than standard telephone wire, it is much less susceptible to interference and can carry much more data. Optical fiber. This technology uses glass or plastic threads, that is fibers, to transmit data. A fiber optic cable consists of a bundle of glass threads, each of which is capable of transmitting messages modulated onto light waves. Fiber optics has several advantages over traditional metal communications lines. Fiber optic cables have a much greater bandwidth than metal cables. This means that they can carry more data. Fiber optic cables are less susceptible than metal cables to interference. Fiber optic cables are much thinner and lighter than metal wires. Data can be transmitted digitally, that is, the natural form for computer data, rather than analogically. T1 and T3 lines. The Tier 1 or T1 is a digital line that is usually private and used for businesses. The businesses that use T1 tend to have more control over their line than other options. It also is considered more reliable. Its speeds are roughly the same or lower than cable and DSL, reaching up to 1.5 Mbps upload and download. Though upload and download isn't amazing, still T1 lines do well for smaller businesses. Tier 3 is a bigger, faster, more expensive version of T1. It can get up to 44 Mbps upload and download speeds. It is great for medium or large businesses as it provides a good deal of bandwidth. T1 and T3 are two common types of leased lines used in telecommunications. Both T1 lines and T3 lines are reserved circuits that operate over either copper or fiber optic cables. Wireless links. Modern age has given rise to information junkies. People normally want to be online all the time. For these mobile users, traditional wire media is of no use. They need to get their hits of data for laptop, palm top or mobiles without being tethered to the terrestrial communication infrastructure. For all such users, wireless communication is the answer. Use of electromagnetic spectrum. When electrons move, they create EM waves that can propagate via space, even in vacuum. When an antenna of appropriate size is attached to an electrical circuit, the EM waves can be broadcast efficiently and received by a receiver some distance away. This is the basic principle of all wireless communication. The radio, microwave, infrared and visible light portions of the spectrum can all be used for transmitting information. Ultraviolet light, X-rays and gamma rays would be even better, but due to their complex nature and harm to living beings, not used. Let's discuss the various types of wireless links in detail. Terrestrial microwave. Terrestrial microwave communication uses earth-based transmitters and receivers resembling satellite dishes. Terrestrial microwaves are in the low gigahertz range, which limits all communications to the line of sight. Relay stations are spaced approximately 48 kilometers, that is 30 miles apart. Microwave radio is used in broadcasting and telecommunication transmissions because, due to their short wavelength, highly directional antennas are smaller and therefore more practical. Microwaves are widely used for point-to-point communications because their small wavelength allows conveniently sized antennas to direct them in narrow beams, which can be pointed directly at the receiving antenna. This allows nearby microwave equipment to use the same frequencies without interfering with each other. Another advantage is that the high frequency of microwaves gives the microwave band a very large information carrying capacity. The microwave band has a bandwidth 30 times that of all the rest of radio spectrum below it. One disadvantage is that microwaves are limited to line of sight propagation. They cannot pass around hills or mountains as lower frequency radio waves can. Typically, microwaves are used in television news to transmit a signal from a remote location to a television station from a specially equipped van. Communication satellite. Satellites communicate via microwave radio waves, which are not deflected by the Earth's atmosphere. The satellites are stationed in space, typically in geosynchronous orbit, which is 35,400 kilometers, that is 22,000 miles above the equator. These Earth orbiting systems are capable of receiving and relaying voice, data, and TV signals. A communication satellite is an artificial satellite that relays and amplifies radio telecommunication signals via a transponder. It creates a communication channel between a source transmitter and the receivers at different locations on Earth. Communication satellites are used for television, telephone, radio, internet, and military applications. Radio waves. Wireless local area networks use a high-frequency radio technology and a low-frequency radio technology. Wireless LANs use spread spectrum technology to enable communication between multiple devices in a limited area. Radio waves are a type of electromagnetic radiation with wavelengths in the electromagnetic spectrum longer than infrared light. Radio waves have frequencies from 300 GHz to as low as 3 kHz and corresponding wavelengths ranging from 1 mm, that is 0.039 inches, to 100 kilometers, that is about 62 miles. Artificially generated radio waves are used for fixed and mobile radio communication, broadcasting, radar, and other navigation systems, communication satellites, computer networks, and innumerable other applications. Cellular network. The cellular systems divide the region covered into multiple geographic areas or cells. Each area or cell has a low power transmitter or radio relay antenna device to relay calls from one area to the next area. The cellular network is typically distributed over land areas called cells, each served by at least one fixed location transceiver known as a cell site or base station. This base station provides the cell with the network coverage, which can be used for transmission of voice, data, and others. In a cellular network, each cell uses a different set of frequencies from neighboring cells to avoid interference and provide guaranteed bandwidth within each cell. When joined together, these cells provide radio coverage over a wide geographical area. This enables a large number of portable transceivers, for example, mobile phones, pagers, etc., to communicate with each other and with fixed transceivers and telephones anywhere in the network via base stations, even if some of the transceivers are moving through more than one cell during transmission. Infrared. IR, that is infrared Wireless is the use of wireless technology in devices or systems that convey data through infrared, that is IR radiation. IR wireless is used for short and medium range communications and control. Some systems operate in line of sight mode. This means that there must be a visually unobstructed straight line through space between the transmitter, that is source, and receiver, that is destination. Other systems operate in diffuse mode, also called scatter mode. This type of system can function when the source and destination are not directly visible to each other. Main characteristics of this kind of wireless optical communication is physically secure data transfer, line of sight, that is LOS, and very low bit error rate, that is BER, that makes it very efficient. The main reason for using IR has been wireless data transfer over the last 1 meter using point and shoot principles. Thus, it has been implemented in portable devices such as mobile telephones, laptops, cameras, printers, medical devices, TV remote controls. Bluetooth is a wireless technology standard for exchanging data over short distances, using short wavelength UHF radio waves in the band from 2.4 to 2.485 GHz from fixed and mobile devices, and building personal area networks, that is PANs. It can connect several devices, overcoming problems of synchronization. Bluetooth is basically a standard wire replacement communications protocol primarily designed for low power consumption, with a short range based on low-cost transceiver microchips in each device. Because the devices use a radio, that is broadcast communication system, they do not have to be in visual line of sight of each other. Range is power class dependent, but effective ranges vary in practice. Wi-Fi. Wi-Fi is a local area wireless computer networking technology that allows electronic devices to connect to the network, mainly using the 2.4 GHz, that is 12 centimeters, UHF, and 5 GHz, that is 6 centimeters, SHF radio bands. The Wi-Fi Alliance defines Wi-Fi as any wireless local area network, that is WLAN product based on the Institute of Electrical and Electronics Engineers, that is IEEE 802.11 standards. Many devices can use Wi-Fi, example personal computers, video game consoles, smartphones, digital cameras, tablet computers, and digital audio players. These can connect to a network resource such as the internet via a wireless network access point. Such an access point or hotspot has a range of about 20 meters, which is about 66 feet indoors, and a greater range outdoors. Hotspot coverage range can vary. RFID, Radio Frequency Identification. Radio Frequency Identification, that is RFID, is the wireless use of electromagnetic fields to transfer data for the purpose of automatically identifying and tracking tags attached to objects. The tags contain electronically stored information. Some tags are powered by electromagnetic induction from magnetic fields produced near the reader. Some types collect energy from the interrogating radio waves and act as a passive transponder. Other types have a local power source, such as a battery, and may operate at hundreds of meters from the reader. RFID tags are used in many sectors like logistics, shopping malls, manufacturing assembly lines, etc. GPRS, General Packet Radio Service. GPRS is a data service technology that enables 2G telecommunication networks to provide services other than voice calls. These services include access to email, multimedia messaging, and a somewhat limited access to the internet. It was mostly used by old mobile sets. GPRS communicates with terrestrial cellular towers. GPS, Global Positioning System. GPS is simply navigation that your phone can use to get you from place to place through a wireless provider's network. GPS is Global Position System which uses timings from satellites to determine location. It has no relation to GSM or GPRS except in the case of AGPS, that is assisted GPS, which might use mobile data provided via GSM, that is GPRS, to quickly get data needed to calculate your position. That would take 1 to 2 minutes to receive from the GPS satellites directly. WiMAX, Worldwide Interoperability for Microwave Access. It is a family of wireless communications standards designed to provide 30 to 40 megabit per second data rates, with the 2011 update providing up to 1 gigabits for fixed stations. WiMAX is a standards-based technology enabling the delivery of last-mile wireless broadband access as an alternative to cable and DSL. Network protocols. 4 layers of networking. The Internet Protocol Suite is the computer networking model and set of communications protocols used on the Internet and similar computer networks. It is commonly known as TCP/IP, Transmission Control Protocol, that is TCP, and the Internet Protocol IP. TCP/IP provides end-to-end connectivity specifying how data should be packetized, addressed, transmitted, routed, and received at the destination. This functionality is organized into 4 abstraction layers, which are used to sort all related protocols according to the scope of networking involved. Layer 1. Network Access Layer. Network Access Layer defines details of how data is physically sent through the network, including how bits are electrically or optically signaled by hardware devices that interfere directly with a network medium, such as coaxial cable, optical fiber, or twisted pair copper wire. Layer 2. Internet Layer. Internet layer packs data into data packets known as IP datagrams, which continue source and destination address, that is, logical address or IP address information that is used to forward the datagrams between hosts and across networks. The Internet layer is also responsible for routing of IP datagrams. Its job to allow hosts to insert packets into any network and have them to deliver independently to the destination. Layer 3. Transport Layer. The purpose of Transport Layer is to permit devices on the source and destination hosts to carry on a conversation. Transport Layer defines the level of service and status of the connection used when transporting data. Layer 4. Application Layer. Application Layer defines TCP/IP application protocols and how host programs interface with Transport Layer services to use the network. Application Layer includes all the higher level protocols like DNS, that is Domain Naming System, HTTP, that is Hypertext Transfer Protocol, Telnet, FTP, that is File Transfer Protocol, SNMP, that is Simple Network Management Protocol, SMTP, that is Simple Mail Transfer Protocol, DHCP, that is Dynamic Host Configuration Protocol, etc. Network Types. There are several different types of computer networks. Computer networks can be characterized by their size as well as their purpose. The size of a network can be expressed by the geographic area they occupy and the number of computers that are part of the network. Networks can cover anything from a handful of devices within a single room to millions of devices spread across the entire globe. Let's discuss some major kinds of networks based on size and span. PAN, Personal Area Network. Such networks let devices communicate over the range of a person. It used for data transmission among devices such as computers, telephones, and personal digital assistants. For example, Bluetooth, Embedded Medical Device Operations, RFID. LAN, Local Area Network. It is privately owned network that operates within a nearby a single building like home, that is home network, office or factory. LANs are widely used to connect PCs and consumer electronics to let them share resources. Example, printers, and exchange information. Example, Wi-Fi. Wireless LANs. WLAN. WLAN are very popular these days at places where it is too much trouble to install cables. Compared to wireless networks, wired LANs exceed them in all dimensions of performance. It is just easier to send signals over a wire or through a fiber than through the air. The topology of many wired LANs is built from point-to-point links. The most common type of wired LAN is known as Ethernet, that is IEEE 802.3. MAN, Metropolitan Area Network. Such a network covers a city, for example, cable TV network. WiMAX, WAN, Wide Area Network. Such a network spans a large geographical area, often a country or continent. For example, VPN, that is Virtual Private Network. ISP, that is Internet Service Provider. Cellular Telephone Network, 3G satellite communication. Network topology. Network topology is the arrangement of various elements, that is links, nodes, etc. of a computer network. Physical topology is the placement of the various components of a network, including device location and cable installation. While logical topology illustrates how data flows within a network, regardless of its physical design, distances between nodes, physical interconnections, transmission rates, or signal types may differ between two networks, yet their topologies may be identical. Overall, we will discuss 6 types of network topologies one by one. Bus topology. In local area networks, where bus topology is used, each node is connected to a single cable by the help of interface connectors. The central cable is the backbone of the network and is known as the bus, thus the name. A signal from the source travels in both directions to all machines connected on the bus cable until it finds the intended recipient. Because the bus topology consists of only one wire, it is rather inexpensive to implement when compared to other topologies. Additionally, because only one cable is utilized, it can be the single point of failure. Star topology. In local area networks, with a star topology, each network host is connected to a central hub with a point-to-point connection. So, it can be said that every computer is indirectly connected to every other node with the help of the hub. In star topology, every node, that is computer, workstation, or any other peripheral, is connected to a central node called hub, router, or switch. The switch is the server and the peripherals are the clients. All traffic that traverses the network passes through the central hub. The hub acts as a signal repeater. The primary disadvantage of the star topology is that the hub represents a single point of failure. Ring topology. A network topology is set up in a circular fashion in such a way that they make a closed loop. This way, data travels around the ring in one direction and each device on the ring acts as a repeater to keep the signal strong as it travels. Each device incorporates a receiver for the incoming signal and a transmitter to send the data onto the next device in the ring. The network is dependent on the ability of the signal to travel around the ring. When a device sends data, it must travel through each device on the ring until it reaches its destination. Every node is a critical link. In a ring topology, there is no server computer present. All nodes work as a server and repeat the signal. The disadvantage of this topology is that if one node stops working, the entire network is affected or stops working. Hybrid topology. Hybrid networks use a combination of any two or more topologies in such a way that the resulting network does not exhibit one of the standard topologies. For example, bus, star, ring, etc. For example, a tree network connected to a tree network is still a tree network topology. A hybrid topology is always produced when two different basic network topologies are connected. Two common examples for hybrid network are star ring network and star bus network. Mesh topology. A mesh network is a network topology in which each node relays data for the network. All mesh nodes cooperate in the distribution of data in the network. Mesh networks can relay messages using either a flooding technique or a routing technique using self-healing algorithms. Self-healing allows a routing-based network to operate when a node breaks down or when a connection becomes unreliable. As a result, the network is typically quite reliable, as there is often more than one path between a source and a destination in the network. Network strategy. Architecture types. Strategy is a way of coordinating the sharing information and resources. There are various major network strategy types to which we will explain one by one. Terminal server. A central computer, that is terminal server, stores all your important programs which are necessary for users. You connect your applications by end machine other than the terminal server. There is no need to install your programs on all your machines. A solution with terminal server, you only need a computer with monitor, keyboard, mouse and network adapter. In a terminal server network, processing power is centralized in one large computer with capacity to handle a large number of connections. The nodes connect to this host computer are either terminals with little or no processing capabilities or microcomputers running special terminal emulation software such as Windows Remote Desktop. Client-server describes the relationship between two computer programs, in which one program, the client, makes a service request from another program. The server, which fulfills the request. In a network, the client-server model provides a convenient way to interconnect programs that are distributed efficiently across different locations. P2P, peer-to-peer. Peer-to-peer, P2P computing or networking is a distributed application architecture that partitions tasks or workloads among peers. Peers are equally privileged, equipotent participants in the application. They are said to form a peer-to-peer network of nodes. Peer makes a portion of their resources, such as processing power, disk storage, or network bandwidth, directly available to other network participants without the need for central coordination by servers or stable hosts. Peers are both suppliers and consumers of resources. In contrast to the traditional client-server model, where only servers supply, that is send, and clients consume, that is receive. Peer-to-peer networks are generally simpler, but their performance usually decreases when there is heavy load. Organizational scope. Computer networks in organizations have evolved over time. Most large organizations have a complex and wide range of different network configurations, operating systems, and strategies. Integrating or connecting all of these networks is a big task. There are various types of internet technologies which are deployed by organizations. Let's discuss them one by one. Organizational scope. Computer networks in organizations have evolved over time. Most large organizations have a complex and wide range of different network configurations, operating systems, and strategies. Integrating or connecting all of these networks is a big task. There are various types of internet technologies which are deployed by organizations. Let's discuss them one by one. Intranet. It is simply the organization's own private internet version. Extranet. It is a private network that connects more than one organization. It functionally provides outside access to an organizational intranet. Firewall. It is a special security system designed to protect an organization's network against external threats. It consists of hardware and software that control access to a company's intranet or other internal networks. Proxy server, that is running either on dedicated hardware or as software on a general purpose machine, may act as a firewall by responding to input packets in the manner of an application while blocking other packets. A proxy server is a gateway from one network to another for a specific network application, in the sense that it functions as a proxy on behalf of the network user. Network bandwidth classification. Transmission channels. A transmission or communication channel is the link or path between sender and receiver. Let's discuss major categories. Narrow band. These channels range in speed from 45 to 300 bps, that is bits per second. This channel is mainly used for telegraph line and low-speed terminals. Voice band. These channels can transmit data at speeds up to 9600 bps. Its main use is in ordinary telephone voice communication. Broadband, wideband. These are used when large volumes of data are to be transmitted at high speed. Data transmission rate of this channel is 1 million bps or more. These channels are used for high-speed computer-to-computer data communication. For example, cable TV, DSL, and fiber optic. Uses of computer networking. Let's discuss the benefit of computer networking. Communication between individual communications is one of the biggest advantages provided by the computer networks. Different computer networking technology has improved the way of communications. People from the same or different organization can communicate in minutes for collaborating work activities. In offices and organizations, computer networks are serving as the backbone of the daily communication. Sharing resources. In a computer network, resources such as printers, scanners, fax machines, and modems can be shared among different users. Sharing software. In a computer network, Usually, application programs and other software are stored on the central computer. Users connected to a network can access these softwares. Data sharing. Another wonderful advantage of computer networks is the data sharing. All the data such as documents, file, accounts information, reports and multimedia etc. can be shared with the help of computer networks. Network security issues. Security over the internet and over various networks is becoming a very serious concern at this point, since an increasing amount of information is traversing many more points of access. The stage is thus set for unbelievable information sharing on both levels, and so the need for network security is paramount to prevent against countless threats. Security is the ability of a system to protect information and system resources with respect to confidentiality and integrity. Confidentiality. Ensuring that information is not accessed by unauthorized persons. Integrity. Ensuring that information is not altered by unauthorized persons in a way that is not detectable by authorized users. Types and sources of network threat. Attacks are often maliciously used to consume and destroy the resources of a network. In order to properly identify and deal with probable threats, one must be equipped with the right tools and security mechanisms. Attacks are generally classified into two types. Passive attacks. Passive attacks are those attacks in which the attacker's main aim is to obtain the information which is passing over the network. In this, the attacker does not modify the content. Active attacks. It is just opposite to passive attacks. In this, the attacker modifies the original message in some manner. The content of the original message is modified and then the modified message passes over the network. Security risks to home users. The home computer user is often said to be the weakest link in computer security. They do not always follow security advice, and they take actions which leads their trap into threats that compromise themselves. There are a number of pieces of malicious code spreading on the internet through email attachments, known as software vulnerabilities. Information security is concerned with three main areas. Confidentiality. Information should be available only to those who rightfully have access to it. Loss of confidentiality is known as interception. Integrity. Information should be modified only by those who are authorized to do so. Loss of integrity is called modification. Authentication. It helps to prove the identity of the sender. It ensures that the origin of the electronic message or document is correctly identified. Absence of authentication is called fabrication. The most common methods used by hackers to gain control of home computers are Trojan horse programs, backdoor and remote administration programs, denial of service, unprotected Windows shares, mobile code, cross-site scripting, email spoofing, email-borne viruses, chat clients, packet sniffing, etc. Software and hardware issues in networking. A network is defined as a group, which is two or more of systems such as Windows desktop and server platforms that connect together for the purpose of sharing resources. Networks are used to give centralized access, that is secure access to networked resources, and generally the entire network, whether it be a home-based office or a corporation's infrastructure, all connect up to the biggest shared resource in use today, the World Wide Web. Let's discuss few major issues one by one. Initial configuration. The first problem that comes to mind is glitches that occur when configuring your network, your systems, and resources for use. There are many components to a typical network, and as size and use grows, so do its complexities and the possibility for problems to arise. There are various ways of doing things, and so the best practice should be considered and followed. When setting up your systems, the biggest things that cause disruption are loss of your main power source, incorrect cabling or wireless configuration, lack of or misconfigured protocols such as IP, and problems with Windows systems such as misconfigured network services. Network performance. This is by far the most common issue with networking in general. If network performance is impacted, either the network is too slow, that is very common term, or the application was not developed with the network in mind. It can be confusing to solve this type of issue and normally requires advanced analysis of the problem to solve. Speed and latency issues can be the result of slow connections or from a network that is saturated with data. Also, using a hub instead of a network switch that keeps a switching table in memory can cause major issues with speed and latency. Other issues that relate to performance or security that tie up your system's resource or purposely cause your services to fail. Internet browsers can also cause an issue, especially if they are infected with a virus. So make sure that this is not the case, or that your system's browser settings are not restricting sites. TCP/IP and other protocol problems. Here are some reasons why this can be an issue. To name a few ISP-based protocol issues: DHCP, DNS, IP addressing, and or using a different protocol suite other than TCP/IP within your network. You can solve most of your TCP/IP related problems by having an updated document of your topology, even if it is a few systems. Being able to view a graphic is extremely helpful when trying to resolve a network issue or to quickly add a new host to your network without causing an issue. At a high level, usually corporate networks, IP packets are routed over multiple devices and links, which takes the problem, that is packet loss, and multiplies it times the amount of gear you are using.